ECG results. So we will take a look at this table today. Okay. So let's go to the report window and see what is the layout like. Okay. So the title of the report is Interpretation of ECG Results Generated on Safety Analysis Set. And let's annotate this table to see which variables do we need and which uh, observations we will be processing. Okay. So I have taken a screenshot of this and this is ready. Okay. So we'll just identify the components of interest for us. Okay. So my ECG dataset could have different kinds of observations. Say for example, I could have my PR interval, I could have my QRS interval, QT interval, I could have my ECG heart rate, and I can have my pulse rate also collected in ECG dataset. Okay, so out of which we are performing analysis on the overall interpretation of the ECG. So how do we interpret it, whether it is normal or abnormal, and if it is abnormal, so whether that ECG result is clinically significant or not clinically significant. Okay, so out of the entire ECG results, we are only analyzing the result of our interpretation of the ECG result, which means we are out of the multiple tests, possible tests in ECG, we are conducting our analysis on one of the tests, which is the interpretation of the overall ECG. Okay, and the second component is we are being asked to generate this output on safety analysis set. What does safety analysis set indicate? It is the subset of subjects who are being dosed at least once. Okay, and then let's see what are the treatment columns displayed. So we have the treatment columns displayed. We are grouping the report based on the values present in our treatment variable, and we also have our total column created here. So what are the components? The third component is the treatment values, and the fourth component for us is to create the total column as well. Okay, and next let us see how are our rows created. Now it looks like the rows are processed based on the values present in the time variable. Okay, the ECG could be performed at multiple time intervals. So in this example we have the ECG results collected at baseline, and again at week 4, and again at week 12, and again at week 16. Okay, so we need this information to identify on how our ECG results are collected. Okay, and again we need to understand the variable from which these values are coming. Okay, and so what are the other components we have? So we are presenting the, here it is n, which is the number of subjects, and we are also presenting the percentages. Okay, we are also presenting the percentages. Okay, so if we are presenting the percentages, we are interested in knowing how the percentages are calculated. So in this example, the percentages are calculated based on the number of subjects with available data at that particular visit. Okay, based on the number of subjects with available data at that visit. So earlier we have used the number of subjects when we were when we are doing the demographics table. We have obtained the denominator as number of subjects with non-missing data for that particular variable. So say for example, we have identified the number of subjects with non-missing sex value and use that denominator as denominator for that subjects in that treatment. Okay, and yesterday we have worked on the adverse events table, on the overview of adverse events table. What was the denominator there? It was the number of subjects available in that treatment. Okay, so we have seen two different types of denominators till now. So here we are seeing a third definition of our denominator. So here it is the number of subjects with non-missing results at that time point. Okay, so for baseline, my denominator would be the number of subjects with non-missing result for the interpretation test at baseline. So what would my denominator for week 4 be? Number of subjects with non-missing result for interpretation test at week 4. Okay. Similarly, at week 12, the number of subjects with non-missing data for interpretation test would become my denominator. Okay, would become my denominator. So we have the seventh component now, which is our n. Okay, which is our n, the number of subjects. The eighth component is percentages. Okay, and let's also try to understand where these values are coming from. So these values, the time, baseline, week 4, week 12, and week 16 are part of a variable. So yesterday when we were doing the overview table, the rows were independent. So they were not part of the unique values of a variable. But here in this case, these values are part of a variable. We'll just see that in a while. Okay. And here also we have these values. Okay. These values are the part of the result variable. Okay. These values are the coming from the result variable. So we have the result variable as eval c here, but this is a newly created row. We will not have any value in the data with a value of n. So this n indicates the number of subjects with available data. Okay, number of subjects with available data at that visit. Okay, number of subjects with available data at that particular visit. Okay, number of subjects with available data at that particular visit. Okay, so let's go to our SAS session and see that. Okay, so I have run some other SAS program. Okay, and I have my data sets, other data sets available in work library. So which procedure can I use to delete the data sets stored in work library? So I can run my proc data sets. Okay, and what is the library which I am interested in working on? So work library is work, and I want to delete the data sets only. Okay, so I'm indicating to SAS that okay, apply this procedure on only the data set. Okay, so this would delete all my data sets present in work library till this point. Okay, so now you see all the data sets in work library are deleted. Okay, also I have the data for this table stored in my local system in particular folder. So I am calling that data file using the %include statement. So after that, what do we need to do? So let's check the descriptor portion for our input data sets. Okay, so let's run this %include file and see how many data sets are getting created for us in the work library. Okay, so we have %included the file and we have two data sets being created. The first one is ADEG and the second one is ADSL. Okay, let's see the descriptor portion for both these data sets. Okay, check the descriptor portion for input data sets. Okay, so how can we check the descriptor portion? We can use our proc contents. Okay, proc contents procedure to check the descriptor portion of the data sets. Okay, I am using my varnum keyword because I am interested in checking the variables in the order in which they are created. Okay, the second data set is input data set for us is ADEG. Okay, so what does ADEG stand for? Analysis data set for ECG. Okay, analysis data set for ECG. Okay, I am checking the descriptor portion for. Okay, I am clearing my output window. I am clearing my log window. Okay, running it. Okay, so here is my descriptor portion for ADSL. The dataset name is work.adsl. How many number of observations are there in it? 41 observations, and 3 variables are present in it. So we'll just go and see what are those variables and what are the lengths and other different attributes of those variables. So I have 3 variables: u sub cd, trt01an, and saffl. Okay, saffl. And let's see the descriptor portion for our ADEG dataset as well. So name of the input dataset is work.adeg. Number of observations is 159. Total number of variables is 8. Okay, and so let's see what are the variables. U sub id, parameter code, param. So parameter is nothing but our test value. Okay, test of ECG. Okay, parameter. So the descriptor for param, this will be the short code for the test name. Okay, this will be the descriptor label for param. Okay, for the test. And I have the analysis visit. Okay, and in numeric version and the character version. So we have seen earlier that this is the time. So okay, the time, the description is stored in a variable called a visit, analysis visit. Okay, and the result is stored in a variable called evalc. Okay, evalc. So which means analysis value in character format, evalc, analysis value in character format. And then we have our treatment column, treatment variable, and also our safety flag. Okay, let's try to annotate our table. Okay, so we have, let's also take a look at the unique values present in our. So now I am interested in checking the unique values for which variables TRT01AN and SAFFL. Okay, from ADSL. Similarly, I am interested in checking the unique values. Okay, for let's say the parameter versus param, a visitant versus a visit. Okay, and let's take a look at the values present in evalc as well. Okay, I'm running both of these. Okay, so we have run the freak procedure on ADSL dataset. The unique values in TRT01AN are 1 and 2. So we have 41 records in the input dataset, and all the 41 records have the safety flag populated as Y. Okay, which means all these subjects have taken at least one dose of medication. Okay, and we are seeing the unique values for param CD versus param. Okay, so INTP means interpretation. So these variables are in pairs. The one is the short form, and this param variable is a long representation of the same test. Okay, INTP is the short word for the interpretation test. Okay, and then so a visitant and a visit. So okay, so this is the analysis visit. The time point in which the ECG is collected is stored in a variable called a visit, analysis visit, and we have a parallel variable for a visitant which will have a one-to-one relationship between both of these. Okay, okay. So here we have the unique values present as screening, baseline, week 4, week 12, and week 16. Okay, and we have our result variable eval c. So what are the possible values? Normal, abnormal, not clinically significant, and abnormal, clinically significant. Okay, now we know what are the unique values for these variables, and let's try to annotate which what should be our filters like. Okay, so we are working on interpretation of ECG results. So though in this example data I have kept only the interpretation parameter alone, I may have additional parameters. Okay, so what do I need to do? I can just, okay, write that. Okay, okay, okay. ADEG dot param, so p is equal to INTP. Okay, I need to filter my input data set for this particular test CD alone because I may have additional parameters as well. The second one is, okay, the second one is, Okay, so the second component is to, so here I can make use of my SAFFL variable from ADSL to identify the subjects. So I can bring the information for placebo and active from which variable. I can make use of my ADSL dot TRT01 AN. Okay, and for total I'll need to duplicate it. So which variable has this information about time? So we have seen that this descriptor values were present in the ADEG dot, okay, a visit variable. Okay, a visit variable. Okay, so these values are coming from ADEG dot eval c. Okay, eval c. So this is the information which is needed for us. Okay, now let's switch back to our SAS session and see. Okay, so what is the first thing we generally do? So as I have done this, I am commenting this. Okay, entire section of code because I will not need this for actual programming. Okay, so what is the first thing we generally do? We read the input dataset and create, duplicate our rows. Okay, read and process input datasets for total column. Okay, total column. So the first thing is let's create ADSL01. Okay, so which subjects do we need to filter? So we are interested in only safety subjects. So I am filtering for those subjects who have the safety flag is equal to Y. Okay, and then I need to create my treatment column. So I have my TRT01 AN variable, and then I need to create my total column as well. So for that I am duplicating each record with a value in treatment variable as 99. Similarly, so I need to read my input data set for ADEG and process it. Okay, ADEG. Okay, so which records do I need to fetch? I need to fetch the records of the safety subjects, and param CD is equal to INTP. Okay, param CD is equal to INTP. Here also I need to duplicate the rows. Okay, duplicate the rows for total column. Okay, for total column. So I have done that. So what is the routine step we generally do after getting these things? So we get the denominator totals. Okay, get the treatment totals. Okay, there. Okay, how will we do that? We can use our proc SQL, proc summary, or proc freak. For this example, for this table, let's use proc SQL. Okay, so create table trt underscore totals. Okay, as select. So which variable do we need to select? We need to select the treatment variable, and then we have to count a subject only once. So as denom from which is the input data set. So ADSL 01. Okay, group by treatment. Okay, let's run this all these steps and see if everything worked fine. Okay, so TRT totals got created. We have 19 subjects in treatment 1, 22 subjects in treatment 2, and 41 subjects overall. Okay, 19 plus 22 is 41. So we have our treatment totals created. Okay, so next we need to see, like we have to get the counts for each unique value seen in evalc variable in within each visit, within each visit. Okay, within each visit. Okay, and we also need to fetch the total number of subjects with non-missing value in each visit. Okay, let's try to get this row count first. Okay, total number of subjects with non-missing evalc at each time point. How can we do that? Okay, we'll again, okay, CMNT1, okay, get treatment. Okay, before that, okay, in this variable, so we let's create a parallel variable for our eval c. Okay, if eval c is equal to normal, okay, because our value should be ordered finally such that n comes first, normal comes second, abnormal NCS comes this one like third, and abnormal CS as fourth. Okay, I am trying to create a parallel variable, numeric variable, such that these values come in order. Okay, so if eval C is equal to normal, then let me create a variable called result. Okay, okay, result, and assign a value of true to it. Okay, because this has to come second. Okay, else if eval C is equal to abnormal, okay, not clinically significant, okay, then result is equal to 3. Else if eval C is equal to typo, okay, I'm copying this back and here, okay, clinically significant, then result is equal to 4. Okay, I'm just creating this numeric variable parallel to these variables. Okay, so let's run this and see if this variable is being populated properly. Okay, so ADAG01, how can I check that? I can just cross tabulate between result and eval C. Okay, so if it populated correctly, there should be a one-to-one relationship. Wherever it is normal, the result variable should have a value of 2. Similarly, 3 and 4 for not clinically significant and clinically significant. Yes. So if we missed something, okay, let's say I had a typo here. Okay, so let me run these two. Okay, so if you see abnormal, not clinically significant, result value is coming as missing. So when I run this, I'll know that okay, something is not right with my comparison. I'll know I might have missed something here. I'll fix this and then run the code again to see if this one-to-one relationship is being created properly or not. Okay, now it looks fine. Let's switch to the counts again. Okay, so what is the first definition? So the first counts we are trying to get is for this n row. So number of subjects with non-missing result per INTP. Okay, so the non-missing result is stored in eval C. So where eval C not equal to missing. Okay, where eval C not equal to missing. Okay, so let me get the counts for n row. Okay, n row. So proc SQL is again what I'm using. Proc SQL create table. Okay, so what name should I give? Okay, let's put n. Okay, underscore n as select. So which variable do I need to select? Select treatment. Okay, let me create one more variable because n has to come on the top. I am creating a numeric variable called 1 result and assigning a value of 1. Okay, so here in SQL, instead of using result is equal to 1, we set this value to a variable like this, 1 as a result. Okay, and we need to count the number of subjects. Okay, need to count the number of subjects within each treatment with non-missing data at each visit. Okay, number of subjects with non-missing data at a visit within each treatment. Okay, so count distinct use subj id as count from, okay, from which is that data set ADEG01, okay, where eval C not is equal to missing, group by. So we need to fetch the counts for number of subjects within each visit and treatment with non-missing result. Okay, so I am grouping my records this way. Okay. So number of subjects with non-missing result within each visit and treatment. Okay, within each visit and treatment. Okay, let's run this and see. Okay, row underscore n. Okay, now you see we have got the records. Okay, so there is one other thing. So in the table we are not presenting the screening visit. Okay, we are not presenting the screening visit. So upfront, let's filter for only those visits which are not equal to screening. Okay, let's switch back to our program while reading our input data set. So let's filter for the records which do not have. Okay, I'm fetching only those records with a visit and a visit value not equal to screening. Okay, let me run the entire code again and take a look at our row and counts. Okay, now I don't have my screening visit. Okay, now I have got the counts for the n row. Okay, n row. And then what is the next thing? I need to count the number of subjects who are in normal, abnormal NCS and abnormal CS. Okay, so okay, okay. So I'm using my SQL again to fetch the counts. First as select. So I need to count the number of subjects within a visit, within each treatment, and within each result value. Okay, within each result value. Okay, my result value could have now 1, 2, 3, and 4. So 2 is for normal, 3 is for abnormal NCS, and 4 is for abnormal CS. So I need to fetch the counts within each eval C value, or like we have created a parallel value within which is variable result, within each result, within each a visit and treatment. Okay, and treatment. Let's try to write our code. Okay, a visit and so a visit, treatment, and what is that other additional grouping we need? So within each result as well. Okay, so count of distinct u sub jd as count from ADEG01 where okay, let's say result in 2 comma 3 comma 4. Okay, so we have created our result variable parallel to each of the eval c values. 2, 3, and 4 are of importance to us. Okay, so group by a visit and a visit, treatment, and result. Okay, now let's see. Let's see this. Okay, rows underscore rest. Now I have my counts. Okay, so at baseline visit in treatment 1 with result 2 is normal. Okay, I have 6 subjects. The result abnormal NCS, I have 10 subjects. Okay, with result abnormal clinically significant, I have 2 subjects. Okay, so this is how I got my counts. But what can happen? Okay, so how many visits do I have? Baseline, week 4, week 12, 16. 4 visits. How many treatments do I have? 3. 4 multiplied by 3. Okay, is 12. 12 multiplied by how many results are possible? 1, 2, 3, 4. How many rows are expected? 4 multiplied by 3 multiplied by 3. So 12 threes are 36. How many rows do I have? So I have only 32 rows. So what could happen if you see at week 16 or okay. So at week 16 we do not have a row for result equal to 4. So which means our full template is not ready. What do we need to do? We need to create our full template. Okay, full template. How do we do that? We create a dummy. Okay, we create a dummy. Okay, okay. So what is that is fixed here is the total number of rows here. Okay, total number of rows for each assessment is fixed and my treatments are fixed. So in this current data, I have only data till week 16. What if I get data for week 20? Okay, so I'll not know how many number of visits are present in actual data. So for that I am making use of, okay. So how do I get the unique values present in each in a visit? Okay, I am using my ADEG01 out is equal to visits. Okay, node key by a visit and so a visit. So what would be the result of this syntax? So I would get all the unique rows with, okay, in within each a visit and a visit. Okay, I am only interested in keeping the these two variables. Okay, these two variables. Okay, let's run this and see. Okay, how many unique visits are there? We only have 4 values, so I am getting the unique visit values, okay, seen in the current data. Okay, so let me make use of, okay, we call this as dummy only, dummy 01. I am creating my dummy 02 set dummy 01. Okay, so we can make use of our, okay, make use of our do treatment is equal to do loops, okay, to output the records. Now what would I get? So I have 4 visits and 4 visits multiplied by 3 treatments. I would get 12 rows. Let's see. Okay, 4 visits and I am repeating this. Each observation is being outputted thrice. Once with the value of 1 in treatment and 2 in treatment and 99 in treatment. Okay. Now I am adding one more level to this loop. Okay. 2 result is equal to 1 comma 2 comma 3 comma 4. Okay, one more level to this loop. Now what would happen on the first observation with treatment value 1? So I am asking SAS to repeat this step. Okay, repeat this code the first time as 1 and the second time 2 and third time 3 and fourth time 4. So what would happen? So for the first treatment I would have 4 rows. The first observation for treatment 1, 4 rows would be outputted. Okay, with the value in result variable as 1, 2 and 3 and 4. And then second treatment result 1 2 3 4. So 4 multiplied by 3 multiplied by 4, how many observations would I get? The 36 observation which are needed. Okay, so now dummy 02. Okay, now if you see I have my full template created. So each visit, each treatment, each of the 4 possible visit values. Okay, now what is the case? Now this row n and row rest are present in separate data sets. Now we have to combine them into a single data set. Okay, let's see how we do that. Okay, mnt2, okay, combine row n and row rest data sets. Okay, so how do we do that? We can make use of our appending using set statement. Let's create a dataset called count01 set row underscore n row underscore rest. Okay, row underscore rest. So here I have created 1 as result because this is what is intentional. So I need to have this row displayed on top. So as I know it beforehand that this has to come on top, I have created this result variable in this dataset. Okay, I am combining these two data sets, okay, and fetching it into a data set called count01. Now I have result 1, 2, 3, 4. All the values for the table are coming from this data set. And the next thing is, what do I need to do? So I have to merge my actual and dummy counts. Okay, merge actual and dummy counts, right? Rows. Okay, so proxort data is equal to dummy 0 to, okay, by a visit and a visit. Let me put result and then treatment. Okay, and then similarly I need to sort my counts01 dataset also in same fashion by a visit and a visit, result and treatment. Let's create a dataset named counts02 by merging these two datasets. Counts01 in equal to a, okay, and dummy02 n equal to b, okay, by, sorry, a visit and a visit, result and treatment. Okay, so what would happen for any row which is only present in dummy but not in count01 would get the count variable as missing. Okay, count variable's value would be missing. Let's see that. Okay, so we have seen like there is at baseline in treatment 2 there is no subject with result variable value as 4. So what does that mean? So this means that there is no abnormal clinically significant result in treatment 2 at baseline visit. So we can set it to 0. Okay, we can set it to 0. How do we do that? So if count is equal to missing, then count is equal to 0. Okay, let's run this and see. Okay, counts 0, 2. Now we have set this to 0. Now our counts section is complete. Now we need to calculate our percentage. So what is the definition for the percentage here? So our definition for our denominator is number of subjects with non-missing data. Okay, number of subjects with non-missing data at that visit. Okay, which is nothing but our row n count. Okay, row n is nothing but our denominator now. Okay, so the same component is being displayed here and is used as denominator for these rows. Okay, the number of subjects with non-missing data is displayed as a row and is being used for calculating the percentages for these rows, right? So I will merge this dataset to this entire dataset so that I can use this number as denominator to calculate the percentages. How do I do that? Okay, so I have set the row, concatenated the row and dataset once, okay, so that this row count would be populated, and then I need to merge the same dataset again to this dataset to calculate the percentages. Okay, let's do that. Okay, calculate percentages. Okay, so proxort data is equal to counts01. Okay, my percentages are based on like visit and treatment now. Visit and treatment now. Okay, proxort data is equal to row underscore n is where I have my denominator definition counts a visit and a visit, then treatment. Okay, run data. Okay, this was counts 0, 2, right? Okay, let's create a dataset called count03 by merging counts 0, 2, okay, and row underscore n. Okay, row underscore n. n equal to b by a visit and a visit and treatment. Okay. So what are the variables we have in row underscore n? This count is nothing but our denominator. And what are the variables we are interested in? The by variables and the count variable renamed as denominator. Okay, let's do that. Okay. So I am dropping the result variable as I don't need it. Okay. If I don't drop the result variable present in this row n would be overwriting the values present in the count 02 because we have a result variable here as well. Okay. So for that I am dropping my result variable. Okay. And renaming my okay count variable to denom variable. Okay. Now let's run this and see. Okay. Okay. Count 03. Okay. So now I have my denominators populated. Okay. Now have my denominators populated. And we have one thing, we are not populating the denominator on this row of n. We are only presenting the count value. On rest of the rows, we are presenting the count and percentage if it is not 0. Okay. So we in two places we are not presenting the percentages on the row with n and on the rows a normal abnormal NCS where the value is 0. Okay, where the value is okay 0. Okay, where the value is 0. Let's work on that. Let's create the percentage in a new variable called counts04 set counts03 length of CP. Let's hold the value in a character variable called CP for counts and percentages. Okay. Then if so, what is the result variable's value for n row? It is 1. If result not equal to 1, then do. Okay. So on these rows, normal, abnormal, and NCS abnormal rows, we are not presenting the count. We are not calculating the percentage when the count is 0. Okay. If count not equal to 0, then CP is equal to put of count comma 3 dot. Okay. And then we need to present the percentage in a parenthesis. So I'm concatenating that. How do we calculate the percentage? Count divided by denom multiplied by 100 and convert it into character using 5.1 format. And then let's display the percent symbol. Okay. So what if the count is 0? CP is equal to put of just the count. Sorry. Okay. So what if the result is 1? So this else was for if count not equal to 0, if result not equal to 1. So we have calculated the percentage based on the count variable. So upfront, so when result is equal to 1, so it corresponds to the n row. So there we only have to present the count without the percentage. Okay, without the percentage. Let's run this and see. Okay. Count 04. Okay. Now we have our counts percentages calculated, and what is our only pending thing? So we have this numeric variable, but we have to present those values as n normal, abnormal NCS and abnormal CS, and then bring the treatment columns into treatment rows as columns. So how do we do that? We can transpose it. Before that, let's create a character variable. Okay, let's create a character variable parallel to the result variable. Okay, such that the labels are displayed properly as in the shell. Okay. Okay, let's create that variable here itself. Okay, let's create a variable result C and assign a length of 30 to it again. Okay, so Okay, if result is equal to 1, so what is the value? Result C. How do we need to display it? We have to display it as n. Okay, else if result is equal to 2, okay, then result have to be presented as normal. Okay, else if result is equal to 3, then sorry, this is result C. Result C is equal to abnormal. How is it presented? With a hyphen in between and then CS. Okay, else if result is equal to 4, then result C is equal to abnormal CS. Okay, so when creating this result variable, we have created in such a way that this abnormal clinically significant has a value of 4. Okay, and abnormal not clinically significant has been set with a value of 3. So you have to be double sure like how you are assigning the value here and changing the value here. Okay, and let's run this and see. Okay, count 0 4. Now we'll have the result C variable also created like in the way the shell has to be presented. The final thing is transpose. Okay, data such that treatments are presented as columns. Okay, so what do we need to do? We just need to sort the data set based on the by variables. Okay, count 0 4 by. So what is the first preference? We need to have our visit and then the result variable, result C variable, and then okay, we need to have these columns as columns. Okay, data is equal to counts 0 4, out is equal to okay, out is equal to counts 0 5. Let's say let's add a prefix of trt to the newly created columns. Okay, so which variables do we need to keep as columns? So the visit variables, we need to keep them as columns only, and we also need the result variable and result C variable as columns only. So which variable do we need to transpose? The count percentage variable. And which variables values have to become the names of the columns? The treatment variables columns. Okay, so I am transposing this. Okay, I'm transposing this. Let's take a look at our count 05. This is how our final report layout should look like. Okay, the only thing pending now is, so we have to create the macro variables for column headers, right? Create the macro variables for column headers. How did we do that? So we have used our data step calls input x. Okay, set. So where do we have the treatment totals present? We have the treatment totals present in this data set. Okay, 19, 22, and 41. Okay, so set trt totals. Okay, so call input x of. Okay, so we were concatenating the text n to the unique values present in treatment variable and then storing the value present in denom variable. Okay, the denom variable of trt totals dataset. Okay, symbols. Okay, now what will happen? I will have three symbols created. So what are they? n1, n2, and n99, because we are concatenating n to the value present in treatment column. Okay, in yesterday's case we have the values in treatment column as 0, 54, and 81. Okay, so the symbols created were N0, N54, and N81. But as we are concatenating the value present in treatment variable to the N, the symbol names would now become N1, N2, and N99. Okay, now let's write the proc report for it. Okay, let's write the proc report. What is the data? Input data for us. It is count 05. And then let's use this no window option. And then let's give a line size of 150. Okay. What are the columns that needs to be printed or used for sort order? Okay, so we have to use our a visit n for sort order, print a visit value. Okay, result for sorting, but result c for displaying. Okay, and then our trt1, trt2, and trt99 columns. Okay, so we need to define the column headers and define the widths required for or this thing. So we also need to indicate to SAS that okay to define a visit but do not print it, okay, but order the observations in the report based on the values present in a visit n. Okay, similarly, okay, a visit is what is the label? A visit, the label for it is time. Okay, so you can provide the options in any order, it doesn't matter. So earlier we were using the width option first, but it is not mandatory that you have to use the width first and then the followed by header. Okay, okay, the order can be anything. So here let's say we need some 10 columns wide for a visit. Okay, and then let's say the result column is only for sorting but not printing it. Okay, so here the order does not matter again. It checks for the presence of that keyword and determines whether that to be printed or ordered or not. Okay, and then okay, define result C. So here we have to print this. So let's provide a width of 15 or okay 15 characters. Width is equal to 15 characters. Okay, and then let's see what is the label for it. Label for it is assessment. Okay, I am assigning the label of assessment. And then our TRT1. So let's use a width of 15 for these columns as well. So what is the label for first column? It is placebo. Okay, placebo separated. Okay, okay. Number of subjects. What is the symbol name for placebo here? It is N1. Okay, N1. So we are using this split option as this has to be printed on a new line. We are using this option. So we have to mention in the proc report statement that my caret symbol is the split character. Okay, so and similarly let's copy this. Okay, and treatment 99. So this is our active. So this is our total column. The symbol name for active is 2 and the symbol name for total is